Okay, this video is a continuation of section 1.4 dealing with volume and surface area. So in this video, we're going to talk about surface area. This is part 2 of section 11.4. Okay, the surface area of a three-dimensional object is the total area of the surface and the object. A painter would be interested in the surface area of a room rather than the volume. So I'm going to be looking at surface areas of certain three-dimensional figures, like we'll start off with the right prism and right cylinder. Find their surface areas. Here we use the right quadrilateral prism in this figure to motivate the formula for the surface area of a right prism. As you can see here, if you flatten this prism out to be this, your two bases are going to be the quadrilaterals. And these rectangles represent the lateral faces. Okay. So now, we're going to let B represent the area of the base, and P represent the perimeter of the base, and the height, the H represents the height of the right prism. Here we see the lateral surface area of a prism is the same as the area of a rectangle with dimensions P and H units, or P times H square units. Then that means that the surface area, which is abbreviated SA, of the right prism is going to be this. SA is equal to 2 times the base plus the perimeter times the height, square units. 2B plus pH, square units. That's your surface area. Now let's look at a right cylinder. Okay, so in this figure, you're going to see the surface area of a right cylinder. That's going to be straightforward to compute by considering a net for that cylinder. So here we just kind of take apart the cylinder and just flatten it out in the two-dimensional realm. So when you flatten this out, you're going to see two circles, one at the top, one at the bottom. Each circle has an area pi times the radius square on the top and the bottom. And then this length right here is going to be the circumference of that circle, which is 2 pi r, and then your height. Okay. So if we cut along the edge of the bases and unfold the lateral side, we obtain a rectangle with the dimensions of H units, that's the height of the cylinder, and 2 pi r units, which is the circumference of the bases I mentioned. So here, this is the following here represents the surface area of a right prism and a right cylinder. In this case, for the right prism, with a perimeter of P units and the area of B square units, and the prism has a height of H units, the surface area would be this formula. SA is equal to 2 times B plus P times H square units. Keep in mind, the base could be anything. It could be a triangle, it could be a square, it could be a rectangle, or it could be a pentagon or a hexagon. Doesn't matter. You have to use the appropriate formula for those, for the base of whatever that base is. And if a right cylinder has a radius of r units and the height of h units, in the surface area would be this. SA is equal to 2 pi r squared. That represents the area of the two circles, one on top, one on the bottom, plus 2 pi RH. That's the lateral surface area. And that answer will be in square units. So take a look at example 58. A regular hexagonal prism has a base with sides. Okay. All right. Pardon the interruption. A rectangular hexagonal prism has a base with sides of the length 15 centimeters and an apothem of 13 centimeters. The height of the prism is 20 centimeters. And we're answering parts A, B, and C. What is the area of the base? What is the lateral surface area? And what is the surface area of the prism? So in this case here, the diagram is a net for the hexagonal prism. Okay, so now we're going to find the base. Now it is a hexagon, so we have to use the formula 1/2 the perimeter times the apothem. The perimeter is, a hexagon has 6 sides, so that's going to be 6 times the length of the side was 15. So that's 6 times 15 times the A, which is your apothem, that's 13. Multiply that out, you get 585 square centimeters. That's going to be the base. And then perimeter times the height. Well, that's 6 times 15 that we found. The perimeter, there's 6 sides. Each side is 15 centimeters long. 6 times 15 times the height, which is 20. That would give you 1,800 square centimeters. And then to find the surface area, which is part C, we just add, we do this. 2 times the base, that's 2 times 585, plus the perimeter times the height, which we found to be 1,800. So 2 times 585, that would be 1,170 plus 1,800, which will be 2,970 square centimeters. That represents the surface area of that entire right hexagonal prism. Take a look at problem number 7 on page 690. We're going to do that one. The diagram represents a right pentagonal prism. The measurements unit is feet. So in part A, we're going to find the area of the base. And then part B, we're going to find the lateral surface area. And then part C, find the surface area of the prism. Okay, let's identify what we already have. We do have an apothem. That's this down here. That's 10.3. That's your A. Now we need to find the perimeter of this. It is a pentagon, so the perimeter would be 5 times S, which is in this case 5 times the length of the side is 15. So if I do 5 times 15, this will give me 75, and this is in feet. So it's the apothem. It's also in feet as well. So if I want to find the area of the base, this is going to be part A. I'm going to say B is the base. That's going to be 1/2 the perimeter times the apothem. So I do 1/2 times the perimeter of 75 times the apothem of 10.3. This will give me, in this case, I came up with 386.25 square feet. That's the area of that base right there. Now part B, find the lateral surface area. And I'm going to abbreviate this as LSA, the lateral surface area. That's the perimeter times the height. Well, we already found out what the perimeter is. That is 75 feet. The height is right here. And I might need to say that as well. The height is 18 feet. So P times H, or P times, well, 75 times 18, that would give me 1,350 square feet. And then part C, find the surface area of the prism. So the surface area, or SA, would be 2 times the base plus the perimeter times the height. Well, 2 times the base, well, this will be 2 times that base, which is 386.25, plus the perimeter times height. That's from part B, 1350. So 2 times 386.25 plus 75 times plus that 1350, that would be 2,122.5 square feet. Okay. So that is the surface area of that particular right pentagonal prism. All right, next we'll look at problem number 37, A through C, on page 692. Now this deals with a right cylinder. In this case, this radius is 2 feet, and the height is 3 feet. So as you can see here, the diagram shows a right cylinder, and you're going to do the following. And you're going to round the final answer to the nearest tenth, to 1 decimal place. Okay. So now, the radius is 2 feet. I'll mention that again. The height is 3 feet. So I'm going to find the area of the base. Here, this base is a circle. So the area of the circle, which is my base, that's going to be pi r squared. Okay, so this will be pi times the radius, which is 2, and that's squared. So 2 squared would be 4. So if I do 4 pi in the calculator, or 4 times 3.14159, which is what I will use, this will be approximately, to 1 decimal place, 12.6. Well, I'll just leave it as 4 pi as this answer right here, because I'll do that. I'll come up with a surface area. I'll round that final answer to the nearest tenth. Now, part B is finding the lateral surface area of the cylinder. The lateral surface area in a cylinder is this, the 2 pi r times h. That's the second part of that surface area formula for a right circular cylinder. So this will be 2 pi times r. The r is the radius, that's 2 feet. The height was 3 feet. So if I do 2 times 2, which is 4 times 3, this will be 12. I'm going to leave this as 12 pi. Or better yet, I think they want this to 1 decimal place. So when I did 4 times 3.14159, I rounded this off to 12.6. So this will be approximately 12.6 for part A. And I might as well do 12 times 3.14159 as well. This will be 37.70 square feet. I mean, just feet. I'm right, square feet. And this is also square feet. And then finally, part C is finding the surface area of the cylinder. In this case here, the surface area is 2 pi r squared plus 2 pi r times h. So this will be 2 times what pi r squared was, is 12.6, plus 2 pi r h came up with 37.70. And this will be approximately 62.8 square feet. Okay, that would be the surface area of that particular cylinder. Okay. All right, next we'll look at the surface area of a regular pyramid and a right cone. All right, say so the lateral surface area of a regular pyramid are congruent, isosceles, or equilateral triangles. They're congruent, isosceles, or equilateral triangles here. The slant height of a regular pyramid, which is denoted by lowercase l, is a line segment from the apex of the pyramid to the midpoint of a side of a regular polygon. Slant height. It's at the top of starts at the top of the pyramid, and it goes to a midpoint on the side of a regular polygon. The slant height does not exist for non-regular pyramids because the lateral faces are non-identical. Okay. So, what do I mean by slant height? Take a look at this picture right here. The height is slanted. It's on the face of the pyramid. That's your slant height. That's on the face of the pyramid, starting at the top, being and it ends at the midpoint of a side of that base. And then you have your regular sides, which are there at the bottom, and then you have your height. This is called the vertical height. So that's how we visualize a slant height. All right, the surface area of a regular pentagonal pyramid is easier to visualize by forming a net from unfolding the lateral faces. The lateral surface area of a pyramid is the combined area of the lateral faces. Okay, so this is what they did. They took this apart and flattened it out into this. Looks like a star. In the two-dimensional realm. So the surface area of a regular pyramid with a slant height of L, sides of length S, and height of H and apothem of A, and a base that is a regular polygon within sides is this. SA's surface area, that's the area of the base, plus the lateral surface area. Okay. All right, so now, of course, the way they come up with the formula for the surface area of a regular pyramid would be this. They take 1/2 the perimeter times the apothem, that's 1/2 P times A, and then you got N times 1/2 the base of the triangle times the height of the triangle. The area of a triangle is always 1/2 base times the height, but you have N number of those triangles here. So this simplifies to 1/2 P times A plus N times 1/2 the S, which is the side of that triangle, times the slant height of that triangle. That L is your slant height. Okay, and then 1/2 P times A is equal to 1/2 N times S times L. But here N times S, the number of sides, the number N times the sides, that's the perimeter of that triangle, times the slant height. So that's where that formula is derived. So here, to summarize all of that, this is the following for the surface area of a regular pyramid and a right cone. For a pyramid with a slant height of L units and the base that is a regular polygon with an apothem of A units, the perimeter of P units and the area of B units is given by this. The surface area is equal to 1/2 P times A plus 1/2 P times L. Keep in mind your L is your slant height. And then your surface area the cone is in a circle, so the area of the circle is the pi r squared. And then when you break that apart, this part right here, that pi times the radius times the slant height, represents the surface area, the lateral surface area for that cone. So it's S is equal to pi r squared plus pi r L square units. Let's look at some examples here. Example 59. A regular pentagonal pyramid has a height of 12 centimeters and a base with sides that are 10 centimeters and an apothem of 7 centimeters. And here I want to find the slant height of the pyramid, find the area of the base, find the lateral surface area of the pyramid, and find the surface area of that pyramid. So here we draw a diagram to visualize the relationships. So here's a pentagonal pyramid, a right pentagonal pyramid. The apothem is 7. The length of the sides is 10. This height is 12. The problem is we don't know what the slant height is. That's the height on the face of that pyramid. So if we take that part out, we know we have a right triangle. So here we're going to need to use what they call the Pythagorean Theorem that I talked about in the last video. So here, the slant height is going to be this. L squared is equal to 12 squared plus 7 squared. Your L squared is the hypotenuse. That's the sum of the squares of the other two lengths. 12 squared is 144. 7 squared is 49. Add those two together, you'll get 193. So the square root of 193 is going to be your slant height. And then the B part is finding the area of the base. Well, the base is a pentagon, 5 sides. So we have to use 1/2 the perimeter of that pentagon times the apothem. So that's 1/2 times the 5 sides. Each side is 10. So it's 5 times 10 times that apothem is 7. So 1/2 of 5 times 10 times 7, that's 175 square centimeters. And then part C is finding the lateral surface area of the pyramid. Here's part C. That's the lateral surface area. 1/2 P times L. So it's 1/2 of 5 times 10 times the slant height, which was the square root of 193. Now, if we round that off, you'll get 347.3 square centimeters. Okay. And then finding the total, just the surface area. That's part D, finding the surface area of that pyramid. So in this case here, the area of the base is 175 plus the lateral surface area, which is 347.3. Add those two together, you'll get 522.3 square centimeters. That's the approximate surface area of that right pentagonal pyramid. Excuse me. Take a look at problem number 51 on page 693. It says here, find the slant height of a cone with a radius of 10 and a height of 18 centimeters. Okay. Again, the slant height is going to be the height that's on the face of the pyramid. And it's not the vertical height, because slant height means that the height is slanted on the face of the pyramid. So we're going to have something that's in the form of a right triangle. The radius is going to be 10 centimeters. The height of that cone is 18 centimeters. So if you recall, I'm going to call this L for slant height. We need to use the Pythagorean Theorem. And that's, of course, a square plus b square equal c square. I'm going to let this be A. That's 10. So it'd be 10 squared plus the B. Let that height be B squared. That's 18 squared. That's equal to C squared. Actually, I'm going to let that be L since I'm dealing with a slant height. So this will be L squared. L squared. Let's see. 10 squared is 10 times 10. That would be 100. 18 squared is 18 times 18. That's 324. That would be equal to L squared. And add 324 and 100 together, you'll get 424. That'd be L squared. And to find out what L is, I need to take the square root of 424. Now, I think they want a decimal value for that. So if you do the square root of 424, you'll get approximately 20.6 centimeters. That would be your slant height for that cone. And that's all they asked for in this case. Okay. All right. Now, problems 5A through C. Because in the last video when we were dealing with volume, I've done part D. So now we're going to do part C. Parts A through C. The diagram represents a right pentagonal pyramid. The measurements units is in centimeters. So here we're going to find the area of the base, and then find the lateral surface area of the pyramid, and then find the surface area of the pyramid. Okay. So let's start with part A, finding the base of that particular the area of the base. Okay. Now, let's look at what we have here. The base is a pentagon, 5 sides. So here to find the area of that base, let me pull this up. We have to use this formula. B is equal to 1/2 P times A. Well, I know what A is. That's the apothem. That's from the center to being perpendicular to a side. That's 7.6. So your A is 7.6. The perimeter is 5 times S. So here, the perimeter, well, the length of the side is right here. That is, in this case, 11. So, if I multiply 5 times 11, I will get 55. That's the perimeter, 55. So the base there would be 1/2 your P, which is 55, times the apothem, which is 7.6. So 1/2 of 55 times 7.6 would be 209. And that's in square centimeters. So that's the answer to part A. Okay, now part B is this. They want the lateral surface area of the pyramid. The lateral surface area is found as 1/2 the perimeter times the slant height. The problem with that is we don't know what the slant height is. Okay? That's this height that's on the face of the pyramid. From the tip of the pyramid to the side perpendicular to it. So, if I write this out as a triangle, this is what I have. Here's a triangle here. I know the height is 15, and I know the apothem is 7.6. I know nothing about the slant height. So I need to use the Pythagorean theorem. So that means L squared would be equal to the square of the 15 plus the square of the apothem. That's 7.6. That's squared. Now if I do 15 squared, that's 225. Plus 7.6 squared, that's going to be, let me do 7.6 squared. That's 57.76. And if I add those two together, I would get 282.76. And the square root of 282.76 will be approximately 16.815. That would be the slant height. And then I can find out what the lateral surface area is. That's 1/2 of P, which was 55 from part A, times 16.815. Take 1/2 of 55, multiply by 16.815, you're going to get approximately 462.425 square centimeters. That would be the lateral surface area. And then finally, part D is finding the surface area of that pyramid. Well, the surface area, I have to use this formula. 1/2 P times A plus 1/2 P times the slant height. Well, I already know what 1/2 P times A is. I should know what that is. That's from part A. That's the 209 square centimeters. Plus 1/2 P times L, that's this lateral surface area right there, 462.425. So if I add those two amounts together, I will get 671.425 square centimeters. Okay. Okay. So that's parts A, B, and C of problem number 5. Okay. All right, next we'll look at problems 6A through C. The same thing. We have a right pentagonal pyramid as well. And I'm going to find the area of the base, the lateral surface area of the pyramid, and the surface area of that pyramid. So let's start off with the area of the base. To find the area of the base, we have to do B is equal to 1/2 P times A. Now, before we do anything, we don't know what A is. That's this part right here, from the center of the pentagon to a side perpendicular to it. I know the apothem, that's the 25.2, and I know the height, that's 22. That's also that also forms a right triangle as well. So if I draw a right triangle like this, I know this is 25.2, that's the slant height. And this height is 22. But I don't know what this apothem is. So I need to apply that Pythagorean theorem like I did here. in the other example. So this will be a squared plus the length of that side, 22 squared, equaling to the hypotenuse, the longest side, 25.2, and that's squared. So here a squared will be equal to, the square of 22 will be 484, equals to 25.2, that's squared, 635.04. So if I subtract 484 on both sides, this will be a squared is equal to 151.04, and a has to be the square root of that, which will be approximately, I need to do this on the next line, a is approximately 12.2898 rounded to 4 decimal places. And I can find the perimeter. It is a pentagon. That's 5 times S. Let's see, the length of the side, going back to this, is that 18. So the perimeter is 5 times 18, which is 90. That's your perimeter. So I add the perimeter, and I do have the apothem, the length of the apothem. I can substitute that into this formula for the base. So here, B is equal to 1/2. The perimeter is 90 times the apothem, which is 12.2898. Multiply all this out, you would get approximately 533.04 square feet. 553. .04 square feet. So that answers part A, finding the surface area of the base. And now part B is the lateral surface area, which is, of course, 1/2 the perimeter times the slant height, L. So I have 1/2. The perimeter, I found that out to be 90, and I already know what the slant height is. That was at 25.2. That's the height that's on the face of the pyramid. So if I multiply 1/2 of 90 and 25.2, that would give me 1,134 square feet. And then finally, to find the surface area, that's part C, because I think that's what they want. Find the surface area of the pyramid. That's, of course, this base right here, which is 533.04, because that's the 1/2 P times A, 553.04, plus the lateral surface area, 1134. I mean, 100, yeah, 1134, I was right. So 1134, add that to the 553.04. This will be approximately 1,687.04 square feet. Okay. So that's pretty much what problem number 6A through C is, because we already did part D on the other video. Okay. All right, let's look at problem number 8. This is just answering the question. We don't have to work the problem out, just answer a question. The formula for the surface area of a circular cylinder is this. B is equal to 2 pi r squared plus 2 pi rh. So what does 2 pi r squared represent? This is part A. I know pi r squared is the area of the circle, so if we got 2 pi RH, that means we're looking at the area of 2 circles. So here, those are the area of the bases. So these are the area that 2 pi r squared represents the area of the 2 bases of the cylinder. And then part B, what does 2 pi RH represent? Well, the 2 pi RH, when we were flattening out, when I showed you how the cylinder was flattened out in the 2-dimensional realm, you got the 2 circles on the top. That flat surface represents the lateral surface area. The lateral surface area of the cylinder. Okay, that's the lateral surface area of the cylinder for 2 pi RH. And 2 pi r squared is going to be the area of the 2 bases of that cylinder. Okay. All right, take a look at this one. This is a cylinder that we'll look at. Problem number 39A through C. The diagram shows a cone. I'm going to do the following, rounding the final answer to the nearest tenth. So in part A, you're going to find the area of the base. The area of the base. Now, we're not going to worry about finding this height here, okay? Because the surface area doesn't include the area. The formula for the surface area doesn't include the height. It's a volume that includes the height. Okay. So let's see, the area of the base, I'm going to do part A down here. The base is a circle, so the area of the circle is pi r squared. See, there's a circle right there. And we do have a radius of 6 feet. So this will be, I'm going to use 3.14159 multiplied by the radius, which is 6. And that's going to be squared. So if I multiply that out, well, square the 6, that's 36, and 36 times the 3.14159 will give me approximately 113.1 square feet. So that's part A. Part B is this. Find the lateral surface area of the cone. And I'm going to abbreviate this as lateral surface area. And that's going to be equal to the pi times the radius times the slant height. Here we know what the slant height is. That's 10 feet. So this will be, and I'll say 3.14159 times the radius, which is 6, times the slant height, that's 10. And I'm just going to, multiply all this out, round this up to 1 decimal place, as they say. This will be approximately 188.5 square feet. And I'm not doing this in my head. I did work the problem out beforehand. And then part C is finding the surface area of that cone. Well, the surface area is just going to be the sum of these two. The area of the base, pi r squared, times 2 pi times RL. Okay. So that means, let's see, surface area. That's this number, 113.1, plus the lateral surface area, 188.5. That would be approximately, if you add those two together, 301.6. And that is in square feet. Okay, so that's how we found the surface area of a cone. All right, now the final thing I'm going to talk about is the surface area of and volume of a sphere. Surface area and volume of a sphere. Okay, so let's look at this here. And for the sake of time, I won't be going through all of this, but I will be posting these notes on Blackboard for you to look at it. If you want to look at them, that's fine. But I'm just going to go directly into the formula for the surface area, which is this right here. And volume of a sphere. Because what I just taken down just shows you how those formulas are derived. So here the surface area of a sphere with a radius of r units is given by this. SA is equal to 4 pi r square units. And then the volume of a sphere with a radius of r units is given by this. V is equal to 4/3 pi r cubic units. Okay. So I do have an example of just that. Here we're going to find the surface area and volume of a sphere. The sphere looks like this. Looks like a basketball or any round figure that's in the shape of a ball. This sphere has a radius of 14 centimeters. So let's start off by finding the surface area. And I'm going to label this as SA. That's equal to 4 pi times the radius squared. So I have 4 times, and I'm going to use 3.14159 times the radius, which is 14, and that's squared. So 14 squared is 14 times 14, that's 196. So if you take the 196 times the 3.14159 multiplied by 4, this will be approximately 2,463.01 square centimeters. So keep in mind the area is in square centimeters. And then to find the volume of that sphere, we use 4/3 pi r cubed. So here we got 4/3 times 3.14159 times the radius, which is 14, and that's cubed. So keep in mind that radius is still going to be 14. So if you do 4 divided by 3 and then multiply by 3.14159, then multiply by, let's say, 14 times 14 times 14, you'll get an approximate value of 11,494.04 cubic centimeters. Okay. So that's how we find the surface area and the volume of this particular cube. Okay. All right, so that will conclude this particular section on surface area and volume. Okay. Or volume and surface area. The homework will be available for you on WebAssign for you to complete. Make sure you have that done. Please feel free to email me if you have any questions or comments or anything that needs to be clarified in this video.